There's an aspect of calculation expressions in FileMaker that I've touched on already several times, but which is well worth exploring a little further. I'm talking about the fact that calculation functions need not stand on their own. You can use one function to provide input to another, and you can build whole expressions that you can then use as components in other expressions. This ability to build up calculation expressions by combining multiple functions along with operators and references to data or variables is sometimes referred to as the use of compound calculation expressions. And a function used inside another function is at times called nested. Whatever you choose to name it, the ability to call one function to supply input to another within a single calculation expression opens a world of possibilities, letting you piece together logic using the building blocks of the function library. And once you get the basic idea, it opens up a huge amount of scope. Before launching into the deeper water of compound expressions, let's start with something straightforward. To begin with, if I enter a reference to a field, data field 01, you can see that I have a string of text in data field 01 containing a number of names separated by pipe characters. If I create a new record and enter the left function, then a reference to the data field, and for the second parameter input the number 3, we have a simple function which removes the first 3 characters from the value in data field 1, returning Jan, the first 3 characters in the field. Very straightforward, and using only one calculation function to achieve that. Similarly, if I use the position function, also targeting data field 1, and request the position of the pipe character, starting from character 1 and finding the first occurrence. FileMaker tells us that the first pipe character in the data field 1 field is character number 4. Now if I put these two together, I can create a compound expression. So left data field 1, position data field 1, pipe 1, 1, minus 1. So now in fact the position of the first pipe character, less 1, will return the 3 that I supplied as a numeric value in my previous use of the left function. Here the result again is Jan, but now I'm supplying the second parameter to the left function by using a calculation starting with the position function and subtracting 1 from it. In a similar way, let's look at the use of the middle function. Middle data field 1, let's say starting at character 5 and extending for 4 characters. That will return Lily, but to develop the logic further, I could now locate the position of the relevant pipe characters on either side of the value that I wish to extract and supply them to the middle function for its second and third parameters, that is, in place of the 5 and the 4 in this simple one function example. So I'll duplicate the record, and for the second parameter, I'll enter position data field 1, pipe, starting with character 1, occurrence number 1, and I'll add 1. Adding 1, of course, gives me 5 because the first pipe character is the 4th character, and we need to start extracting the name from the character after the pipe. And similarly, I can establish the number of characters required by finding the position of the pipe character that follows Lily, then subtracting the position of the pipe character that precedes Lily, and then subtracting a further 1. So in this case, position data field 1, pipe, beginning with character 1, occurrence 2, minus. Now I want to subtract the position that I've already computed previously, so I'll just copy and paste that expression, and minus 1. And this compound expression produces the value Lily, just as the simpler expression in which I hard-coded the numbers 5 and 4. Let me go to the calculation demos layout, where I've provided fields with some more room so we can see what's going on. Within this expression, I'll now add some line breaks to separate the elements of the function onto different lines. So the middle function has as its first parameter the text, as its second parameter the starting position, as its third parameter a calculation which produces the number of characters to be extracted. And then on the last line I'll put the closing bracket of the middle function. So we have the middle function, and on each of the successive lines its 3 parameters: text, start position, size of text to be extracted. Now, duplicating the record, I'll go one step further. In place of the occurrence number, I'm going to add a reference to the data field 2 field and subtract 1 from the data field 2 field. I'll now enter data field 2 and data field 2 minus 1 as the occurrence parameter for each of the other instances of the position function in this expression. Now when I enter a number into data field 2, the corresponding value is returned, because the various position functions are using data field 2 to determine which occurrences of the pipe characters in the string supplied by data field 1 will be located and provided to the middle function to determine the coordinates for extracting a value from the starting string found in data field 1. So now, when I supply a number in data field 2, I have a compound expression which performs the trick of extracting the corresponding value from the string supplied in data field 1. The particular example of a compound expression that I've chosen here, the extraction of an item of text from a pipe-delimited array, is just one of the many kinds of calculation operations you can undertake using compound expressions. The ability to build up the logic of a calculation using functions, operators and values to supply the input parameters for other functions, and thereby creating compound expressions, is the key to accessing the immense power and scope of the calculation engine.